100 centimeters in 1 meter. So in order to get cubed, you can't just cube the whole, you can't just stick a cube like here. What you're really doing is you're cubing that whole term and cubing that whole term. There's really a 1 in front of it. So you end up with whatever 100 cubed is, centimeters cubed divided by 1 meter cubed. So you have to cube that whole term. So I think that was another thing. And then the rest, I think we were pretty good. Other than number 16, describe how you would prepare this solution. When you see something like describe, I want to know if you're going into the lab, what glassware are you choosing to use? So now in analytical chemistry, some people have put graduated cylinders, which maybe before you cared about accuracy, that was fine. Now we care about accuracy, so we're going to use volumetric glassware. And then secondly, some people said like they would measure out 50 milliliters of the stock solution and then add 950 milliliters of DI water. So we don't do that anymore because the density of those things actually might be different. So when you add them together, you might not actually get a 1 liter solution unless you're dealing with 100% DI water. So now we use our graduated flasks that have that line and we just fill to the line with DI water. So that's what I was looking for on that question, was the glassware we were using and that we fill to the line on our volumetric flask. But other than that, those were, I think, the 3 things that I saw. Number 1, I think, was just a reading, not an actual ability thing. The 3 things that I was seeing. So we have a homework due this Friday. So homework 2 is due this Friday along with the quiz. We are going to finish our chapter 4 today. And then we're actually going to work some of those homework problems together today. Then on Friday, we're going to start chapter 5 and probably finish chapter 5. And then the next week, you actually have your exam on Friday. So not this Friday, but the following week. So it will be on chapter 2, chapter 4, and chapter 5. Exam on Friday.
Will we have homework for chapter 5?
We will have homework for chapter 5, and it's due Wednesday. So I would knock out our chapter 4 homework. We'll get to work on it today, and then chapter 5 you'll be able to do after Friday. Sound good? Okay, don't forget you have an exam. So like next Monday when I say you have an exam this Friday, it should not be like the oh no face.
Oh, it's next Friday, not the one after?
Correct, September 8th.
Okay.
So like this Friday is our quiz, and then the following Friday is our exam. So after this Friday, we'll have covered all of our content for the exam. So we are going to finish chapter 4. So chapter 4, we're talking about what do we do now that we have all of this data. So we learned about our standard deviation. We learned how to take our mean. Really good question was asked. For the homework, you're going to have to calculate your standard deviation. I want you to do it by hand. Don't like use Excel or your calculator. And we can do one today, but it is this method that like we did together in this problem. So like you take your mean, then you take your differences, sum them together, stick that into your standard deviation equation. I did lie to you. I said you won't ever have more than 3. I meant 4. You won't ever have more than 4 to do. So your homeworks are 4 questions that you have to take 4 data sets that you have to take your standard deviation for. Okay, so we did our standard deviation and our mean. Then we talked about how to propagate our error in our measurements. And then we talked about our confidence interval, and we are always going to be working in a 95% confidence interval. And what does that tell us? So lastly, we're just going to learn one more statistical test, and it is called the Grubbs test. So section 4F has more than this, but the only one we are going to do is the Grubbs test. And this is a test for statistical outliers. Test for significant outliers. So if you remember yesterday, I just like looked at your notebooks and I told you if you should do an 11th measurement or not. And then we're just going to ignore the one that we don't think falls in. In real life, if this was real data, you would have to tell a story with all the data you collect. And if you think you messed up, you would then do this test to prove it really was a statistical outlier, and you can throw it away. But in the real world, if you were doing research and you were like, I don't like that number, exactly what we did yesterday, I don't like that number, I'm just not going to use that, that is actually called falsifying your data. So you're trying to make your data tell the story you want it to. So in order to not falsify your data by just throwing out a point, you would have to do the Grubbs test. So this says that it really is a statistical outlier. And for that calculation, we have a big G. We call this a G calculated. We take the absolute value of the value that we think is the outlier minus the mean of all the points, and we divide that by little s, which is our standard deviation. Then we have a table of Grubbs values, Grubbs test values. These are our G values from the table. So we compare our G calculated to the G table value. And if our G calculated is less, we have to keep that data point. We can't just throw it away. If our G calculated is greater than the G table, then we can reject the data point and throw it away. So a good example of this is the calculation, or is the data that you got yesterday. Like you have 10 values, and you're trying to see if one of them was a little bit of an outlier. We got another value to replace it. So here we have the mass of 12 nails measured, and then we list out the 12 values that we get. Should any of these values be discarded? Are any of them not statistically significant? I do give you the mean and the standard deviation in the question, so we just have to plug into our G. So take a minute and figure out your G value. You're gonna have two. So if you can discard any of the values, it's either gonna be the highest value or the lowest value. So which one of these numbers is our highest?
11.6.
11.6 our highest, so we're going to test that one. And what's our lowest? 7.8. So you're going to test those. So you're going to have two G calculated. You're testing minus the mean, and then it's just the absolute value of it. So you can just ignore the standard or average and divide by the standard deviation. And if you put it into your calculator that way, orders of operations, it's going to do that first and then that. So make sure you put parentheses. Okay, so can you throw out any of those values?
For
Yes.
11.6, there's 1.298.
So can we throw it out, or do we have to keep it? I heard keep with a question mark, and then I heard a throw it out.
Can't you keep the big one? I haven't done that one yet though. So.
I'm sorry, what was the actual G calculated you got for the 11.6 value?
1.297.
And what was it for our 7.8?
2.126.
Thank you. Okay. So that's our G value.
But our G table doesn't go to 12.
Why is it bigger than 2.2?
So it doesn't go to 12, but yes, we can use assumption. So if we have our N is 12, we don't have an actual value, but we see that 10 is 2.290. 2.2 is bigger than both of these. And if you see the trend, the higher your N, the bigger your G value. So if this is already bigger, it's going to be bigger for 12. So our G calculated is less than our G table for both of these. So what does that mean? Can we throw them out?
No.
No, so we have to keep both points.
Where's our N coming from?
Our N is our number of measurements, so that's the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So we can't throw any of those data points away. So moving forward with whatever this experiment is, we have to keep all of those. Even though there's a pretty large standard deviation, they're all significant, so we can't throw them away. Okay, so now we are going to look at our chapter. Our homework number 2, our chapter 4 homework. We're going to spend some time doing it today. We are going to do number 6 together. Okay, so carbohydrate concentration of a glycoprotein is 1, 2, 3, 4, 5 different values, weight percent values. Find the 95% confidence interval for the carbohydrate content. So what is given in this problem? I have all these numbers, and then it's asking for the 95% confidence interval. So this is an equation. So look back in your notes. What equation is this? Confidence interval.
So the value from the table T times the standard deviation over the square root of F.
Beautiful. And it's the mean plus or minus that is our confidence. G is our confidence interval equals. So confidence interval equals the mean x bar plus or minus TS over square root of n. It was correctly said that T comes from the table, so you'd have to flip back to that. S is our standard deviation, N is our number of measurements. So number of measurements we can figure out, T we get from the table, S. It's not given to you in this problem, so we have to calculate our S. So how I like to do it, someone shout out to me what the mean is of all those 5 measurements.
Just sum divided by n.
Yeah, but what's the actual value?
12.54.
I mean, I asked that type of question too. 12.54 is our mean, so then we're going to set up our little column where we take the difference between each of those values and square it. So you should have 1, 2, 3, 4, 5 values there, and then you'll take the sum of all of those. That's what you then plug into your standard deviation equation. So there will be a problem on the exam where you're gonna have to calculate your standard deviation. So it's either gonna be 3 or 4 numbers. And in order for me to give you full points for it, I kind of need to see your thought process here. Because I know calculators can also figure out your standard deviation. If you just give it. And you can figure it sometimes, but you don't actually have to write that out. You can just write that number. Yeah, so yeah, you don't have to actually write that out. You can just write like the values there.
Yeah, it's like 3.
So the 0.00.
Yeah, 0.4.
That sounds so much more right than mine.
Yes. That was a big small. Your sums should be much smaller. So like if you do 12.54 minus 12.6 squared, that's your first one. Yeah, plus 12.54 minus 11.9 squared. Plus.
Oh.
So that's what I write down in the actual. So I write down the squared values, and then I draw a line and add them up. And if you're just done and waiting, this is your homework, so you can work another problem as you wait for the class. Yeah, so I would want that work, yeah, to give you. And you can do it, you can basically skip this and just go straight to here, so get the difference here, and then that's what you straight to them. And that will just save you some time. Yeah, you can finish it. More work right down here.
So since there is already a problem at that place, I don't need to show the 4, right?
Great, so it's just 12.5 plus or minus 5.6. Or yeah, 6. And it's not a problem, it's error, since there's already
Not problem.
error in that place.
Sorry.
I got 0.652 for my sum. Second or different?
Second.
Okay. And then that's what we plug in up here. So that's standard deviation of 0.404. That is now what we plugged in for S. We have to go and look at the T value table and then do square root of n. And remember the T value table is the degrees of freedom. So n minus 1. So what's your n minus 1? Or what value are you going from the table? Yes. I'll click on the top. So your confidence interval ends up being what is it, 4.6 or something? Or 501. But when you think about matching your significant figures, you end up with 12.5 plus or minus 0.5. And don't forget to put your unit, which is weight percent. So, if you got that one, move on to number 9 here. And now we're going to see why we calculate our confidence interval. If you want me to come see your work from that last problem, just if you did not get the values, just make eye contact with me. And I will come. But did you get that number when you put that in? Great, perfect, yeah, exactly. Yeah, so you got that one? You feel good with that? So now we're gonna work number 9. Yes, so when you plug it into this equation, what do you get? Okay, so we'll just write equals 0.5 for us. So that's already saying that there's error in this percent place. So we don't actually care about any of that because this is a tenth is going to the hundreds of thousands. Those are already there. This is what matters. Even though our average is 12.54, so we actually, from our measurements, have more precision when we know all the way to this place. We already know there's error. So again, that's just where the first number is in the error. That's just where it is. So imagine you got it. Now your error, your first place that you see error is this position, so you would just report it as tax.
Okay.
So just report that first. Does that make sense?
Yeah.
And everybody's like, that's not making sense to me. Okay, and then you don't actually have to write this out, you can do that in your calculator, but you need these numbers. These numbers, exactly, this part is what I want to see. Yep, I can figure that out. Yeah, but then save yourself some time, do that in the calculator, but yeah, show me that. So now if you got that problem, we're gonna go on to number 9. You can save yourself time. You don't have to actually write that out. So you can just type that into your calculator, compare it, and then write down that value. Oh, okay, so you're like,
I just wrote it out,
okay,
so you knew I didn't like do it all in my calculator.
yeah. So this, I'm sorry, turns out size. So I'm assuming this number minus this number squared equals this number. So it's like you can do that in your calculator, and then just write that down on your tab.
I did the opposite, I wrote
Right.
this down, but I did it all.
Right. That will probably save you a little bit.
Okay.
I'll come your way.
Why did your answer 12.5
Let's see, standard deviation, and then you plugged it into here, and what did you get when you solved for this?
I have to do plus or minus to get 2 different answers?
No, just get this number. What is this number?
Oh,
Plus or
okay.
minus.
Oh, I see.
So so
Oh,
plug in
that's the
those
mean
three,
number. Okay,
and you should get
thanks.
0.501.
Yeah.
So it's 12.54 plus or minus 0.501.
Okay.
But because there's already 0.5, we don't actually care about this 4 anymore because we're already saying there's error there. So it's just 12.5 plus or minus 0.5.
Okay.
Yeah, so don't actually do the plus or minus
Okay.
calculation.
Thank you.
Are we going to include this in the new, or is this?
No, correct. Yeah, so these are your measurements down here. This is actually what we're comparing it to, so don't worry about that right now.
Oh, we need to see if that's even the plus or minus.
Exactly. And this is why we start to care about her. Yeah, so good question. So you have 4 measurements.
I would feel like you can drop that in there, that would be good, because it was the register, I'll be all
So like if I give you C, S, and N, and I just say, what is the confidence interval? And you're just gonna like, give me the number.
So the one plugging in.
I would just, you don't have to plug it in. I would only just put T times S over square root of N. And you don't have to actually put T times S and then it equal.
It's okay.
Just so I know like what equation is
Stop falling down the stairs.
right
please.
in the.
Oh no. I'm just teasing. It's just been a long time.
So now your question is, does this necessarily fall within the range? So that's what the question is. Does your new method agree with the accepted or the accepted?
Do you want to just see the mean plus or minus?
That's fine. And then I think that looks right from what they had. And then the question is, does your new method agree with the accepted? And the accepted value is this missed standard. So does this value fall within that range? And that's what the question's asking. If it falls within the range, then yes, your new method agrees with a 95% confidence. If it does not,
Maybe I looked at it. I did, I looked at it wrong, you're right.
oh, okay.
There was a room in there.
Thank you. Perfect, be sure to put your hand up. And then the question is, does your new method agree with the accepted answer? So the accepted answer is this missed standard. So does, okay, so then say that's a field. Yeah, this is the T table and minus 1.
It's the way it's over, and that's what it is. And square root of that.
Agree. So that one, that was right, so you got it. What did you do?
This is,
Oh, yeah, okay, yeah, it looks good, yeah, perfect.
sorry, my math, I kind of.
No, I was just upside down, so I just didn't see it, but yeah, I was just checking that that's correct, and no. So that's
Whoa.
That's your standard deviation. Yep, exactly. Yep, and,
So you're confident about only these digits past the place that we measured it? That's impressive. What measurement device are you using?
Yeah, that's what I was maybe the person
Yep.
fractures.
Okay. Do you guys get that?
I got a number. I got a bunch of numbers actually.
Yes, so this is correct. So now, sadly, that's not actually the question that's asking. The question is, does your new method agree with the accepted answer? So this is the standard, so this is the accepted answer. So does it fall within that?
No.
So no, your new method does not agree with the 95%.
So let's put your T values.
Yeah, so then you go to range, so really your range would be point all the way to 3.32. Thank you. So if anything falls within that range, that's your number.
But because what page is it on?
Yeah. So that's your standard deviation. Oh, okay. No, it's not it.
What page? Oh, yeah.
Yes, other than you have too many, like I don't care about that 5, so it's 0.06. And then, yep, that's your range, so does this. Okay, so that doesn't go. This one I just. Yeah, so does your new method agree with the, the content interval? That's what you said, Alex is getting it too, so if you just show your work, it just has to do with how you're carrying your 6 eggs.
Why do you freeze?
It gets me exactly there.
Uncertainty in your measurement.
Alex had it too, so as long as you show your work. Yeah. And for your work and how you carried it. So if you guys got that one,
I mean, there's probably
Move on.
another version to the
just doing homework.
I have a question. So you said, 3.19 is the accepted one, right?
Mm-hmm.
So our new method is being,
The parent one.
oh, nice. I had it backwards for a second.
Okay, so if it falls outside of that range, like the accepted value falls outside of the range, that means that new method you just created is not accurate. It's not finding the
But
true value.
what if NIST is wrong?
Yeah.
So we put a lot of faith in this.
That's what I'm saying.
I know
So
2 people who
industry,
work
so like
there.
my husband works in manufacturing and they like make things to like millimeter levels and they 100% rely on NIST to come in and like check their like millimeters. So we just have full faith in NIST to be correct.
Our standard is wrong,
Yeah. So if you're doing something and like you keep getting things that aren't matching this, normally what you do is like you reorder list standard and like just see if
Just try again.
and just try.
So, you know what, let's just give him another chance.
We'll see. But it could be like how you stored it or like
When do we
campaign it
when do we break up with
or
this?
something.
I would love
Can we stop giving her chances?
Julia got to go to NIST for her internship.
This one? Hold on, I don't actually know.
Their tasking video where Garrett went to, and we saw the 1-ton total balance. Right, yeah, NIST has that 1-ton balance, that like.
Yep,
massive-
so does your new computer agree?
measures the thrust of the rocket. Wait, whoa,
I wanted to this
it might not be. I know she did say total balance.
That's what I got too.
Him standing in front of.
So at this point, you guys can just keep working homework problems. Use this next 10-15 minutes to save yourself 10-15 minutes outside of class to do homework. And then this is due Friday. You have a quiz on Friday on this material as well. So make sure to study for the quiz.
So we say our new method does not agree with that.
So here's the NIST. I will give you the formula for standard deviation confidence interval. So a question was just asked about if you have to memorize formula. I will give you standard deviation and confidence interval. Good question. Yeah, so, but I mean, we can skip to the first page. Okay, yeah.
Not especially.
So the first chapter in every like textbook in chemistry, it's like a review of like all that like surveys and stuff like that. So usually it's just longer, but hopefully it's coming back to you. Yeah, because it's not new.
That was your point. It's all your point.
And just make eye contact or call me over if you guys have a question. Okay, thank you for that eye contact.
Do you want to go
So like a Gatorade bottle would be behind it. Maybe it's just all happens at Gatorade bottles. Remember how close you're coming in? It just looks like.
We're all, and we all do these like every semester.
This is a giveaway, yeah.
Oh, okay.
Yeah, but the entry ticket is $1,000
To be in it.
with a 95%
Oh.
confidence.
This one is coming.
You guys-
Mm-hmm.
Do I need to calculate the
Wait, we're
number
going
of
this year.
numbers or not?
No, so what's in the Grubbs test? What's the equation for the Grubbs test?
I literally just looked at it.
It's our value that you're trying to determine as an outlier, the mean, and the standard
So you
deviation.
just need to find the mean and the standard
The
deviation.
mean and the standard
And then
deviation.
just
Yeah.
push it.
Alex, what was the standard deviation for number 11? So number 11, you guys can just use the standard deviation. You don't have to calculate it. Unless you did already, then it's practice, because you're gonna have to do that.
I'm gonna stop here.
I mean, it's not for fun. I am telling you, on the exam, you are going to have to calculate the standard deviation for something.
So we have to find the CI.
So for this, oh, because you see the 95%. Okay, I see now why you guys are asking that. I'm sorry, real quick to the front. I don't think I said this, and I think this is why it's confusing you. These Grubbs values are coming at the 95% confidence interval. So if you look at number 11, it's saying, can you throw any of these out at the 95% confidence interval? You don't have to do a confidence interval. It's just you're using this Grubbs table, these G values at the 95%. Okay. So I did not say that. So no confidence interval for number 11, just the Grubbs equation. Make sure to see that. It is. Yeah. Okay.
I could do the math.
So, yeah, like, we know that this is
What's your reason for
add 0.05.
So, correct. Make sure to put a unit after that number though.
Is it?
Or you can just take that percent. If all of them have that percent. I don't think I didn't do the key yet, so we're just gonna have to ask your partner.
Alright,
For number 11, are we keeping it or throwing it away?
also,
I'm not finished.
I got confused. Yeah, I don't use that, this is very, pretty good.
Okay, so then that's right here.
So-
Leaves out.
What I did was,
You figured out your grams. Yeah, you got it.
and then I used,
Let's pause. You have grams times grams over moles. You have grams squared over moles. So,
but,
yeah, so we'll flip that and we'll get into moles.
do I defer to that, or do I put these out? Cause I mean, I feel like,
Yes, I left you grams all the way on the bottom. Yeah, that's not written properly.
okay.
So you have to divide by that
Well,
number.
I'm gonna go ahead. It works in my head.
I don't know how to respond to that.
I could not.
If you don't get the right answer though, and then I go back and try to follow the words, because that's what it's, I try to give person credit.
What I did, like, with this being the uncertainty, I did process that to match what you do, and then minus that to the match right here, and then calculated moles, and then got that, so then I used that.
You are complicating this problem.
I thought so.
Our uncertainty is equal to our uncertainty in all of the things, oops, sorry, I don't know why I threw a in there. In all of the things squared. So I told you this was uncertainty in the volume, and then I said we're actually, this is negligible, I don't even know how to spell that word, negligible.
Yeah.
But we don't
So
actually
we only need to
care
worry
about
about
that.
one of them.
Yeah, so you're actually only that error, so you're gonna square it and take the square root of it, which is itself.
Okay.
So you're just gonna now your moles plus or minus 0.00. 1, 2, 3. Or
Which number is
the balance of
you?
I think 4.
Yeah,
Because you answered
0, 0, 2.
Oh.
Cause like you plugged it in.
Yeah.
0, 0, 0, 0, 2 squared plus 9. So we're gonna ignore that. So then it ends up with an uncertainty, the answer is 17.0002.
Okay.
Then on the next question, now we're actually adding our uncertainty together. So we have 0.0002 squared. And what's our other uncertainty?
4. It's almost 500 milliliter. Flat.
So 4 squared.
I did that. I had this one. I don't know.
You don't think 4? Well, yeah, because this is
It's
so
super
small.
small,
That's
but it's
huge.
just
It's like
big
that's
on it.
that's what's carrying it. So I'm sure you got more sig figs after it.
I might have to everything show me. I'm sure they're.
And then for the similarity. And then your other issue is similarity is moles over liter. You did moles divided by milliliters. So now that's probably why you weren't on the same unit range.
Okay.
If that makes sense.
Yeah, that does make sense.
Like you
Because
were off by
I got an
1,000.
uncertainty of 4 and then a really small
Mhm.
number. And I was
But yeah,
like, well,
So you were off by
So
1,000.
I got none of the values to be excluded.
Okay.
Okay. So guess that's the answer.
Yeah.
I had some quick questions. I feel like I'm overthinking these ones. So for this one, can you just subtract using a 5 mil and it moves 2 mils? For a different one?
Yeah, so he got 3, so your magnitude of measurement is 3.
Okay.
When you propagate error, you're always adding it.
Right.
though.
So then that's right. Okay. So that's fine. This one, I'm confusing myself because it's like it uses a 1 ml pipette 5 times. Like
So
that's
you have to propagate the circle 5 times. So 1 mil plus 1 mil plus 1 mil plus 1 mil plus 1 mil.
oh, plus each of those uncertainties.
So the uncertainty in the 1 mil 5 times because you use the pipette 5 times.
And then this one is just a graduated
Comparing
cylinder.
it.
I assume she uses a 5 ml graduated cylinder because that's
So yeah, so
and
you
so
have to
then-
propagate in 1 mil.
and so then I just compare those two absolute uncertainties and see which one is
Smaller.
smaller.
Mhm, yeah.
Okay, I was over. Not way too much.
So every time you use a piece of glassware, that's an uncertainty.
So even if you remove it,
Yeah.
okay, that
Every
makes sense.
time you use it, you're to add that uncertainty together.
Okay, that makes sense.
Yeah, but that was fun. That was just.
No, I mean, that's a big number as well. But it's a big number and it's a big number. But I don't know.
The rest of it's easy.
I didn't. Did you burn?
Is this a joke or is this a question? Are you like setting up?
I like that never happened. It was so
I
short.
haven't had a nose
I know. I was like,
Okay.
yeah, I was like,
It's one of those weird things that happens like out of the blue and you're like, what? Yeah, exactly.
it was strange.
That was the best response.
Let's see. Alex, I'm gonna do number 4. We have like 1 more minute, but I'll do number 4 and I'll let you know what is going on. Okay, so you guys have 1 minute, so you can pack up if you'd like, or hang out.
A man of the people, straight to the consumer. No middle. Nobody should be.
So homework due Friday, quiz Friday. Friday.
I forget the last one.
I brought it in.
Forget the last one.
Are you a grand question following?
I am. You have a good chunk of us pieces that are all on it. Chris is in here, Alex, Hunter. Oh god.
Who's teaching it this year?
There's a Burkhart. If you ever do a concert. She's nice. She's really nice.
Yeah, but there's like a small one where
It's
you.
also about 4 and 5.
Oh,
I don't know
okay.
if you will do that one.
Yeah.
Alright, I have a TA.
Slide it.
So I'll see you.
We have one of those.
Are you going to the review session?
Probably. I mean, I think it should be. It's tonight. No, it's tomorrow.
Today Wednesday?
Today's what this is. Tomorrow.
Wednesday. Oh, it's Thursday.
Yeah, he changed it to be Thursday at 6, so it's after his
Career and professional.
120 lecture. He has like a 120 review session, so I was right after.
Alex, I figured it
Long day
out.
for him.
So you were putting in 4 mils in your air and squaring it, but molarity's in liters, so it needs to be 0.00,
Yes. Okay.
right? 4 mils,
Yeah.
0.004. So 004 squared, and then that will match up sig fig size.